All right, so with putting this on last night's homework, it's going to make the questions count off a lot less. So this extra practice, Gaussian elimination, I'm going to do the first two, and then it's in Canvas, and y'all can pull it up so you can see it better with after that. I look at the x's, and I say, well, I'd have to change both formulas to make a 4 and a 5 alike, right? But when I look at the y's, they already are going to drop out. Would everybody agree with that? So see why I said you should check your y's? Now, are they going to drop out as in, not just they're the same number, but they're opposites, right? That's what they got to be. They got to be opposites to drop out. So when these two drop out, what do I get? Close. 15. All right. So that's a problem because 9 doesn't go into 15 evenly. Everybody see that? So my x point, the x part is 15, yeah, the x part, 15 over 9. But I don't have the y part, so I have two choices now. I can take that answer for x, and I can plug it in one of these formulas and solve for y, or I can go back and try solving for x. Excuse me, not solving for x, but make x drop. Which do you think would be easier? Plugging a fraction in for x, which is going to stay a fraction all the way to the end, or switching these two numbers and working it so the x's drop out so I can calculate my y. All right, so we're going to try that on this one. It was easy to get the y's to drop out to the get-go, but now, oh, I'm going to talk about that in a minute. Yeah. So, let's talk about what can make a 4 and a 5 alike. Well, what's the number that 4 and 5 both go into? 20. So if I make them both 20, that'll make them both positive 20, right? If I just switch the two numbers? Don't I need one of them to be negative? So I always make the bottom row do that. Now, it's not wrong to make the top row do it. I just find it easier to work with it on the bottom. So that's going to give me 20x minus 5y equals negative 30. And negative 20x minus 4y equals negative 84. So those are going to be some pretty big numbers, so I'm glad we're not doing this the other way. So now my x's drop out, giving me negative 9y again, and that adds up to what? Negative 114, okay? So if I divide by negative 9, okay, let me try that again. I need to really orientate this board. Then that's going to be 114 over 9. Now, I don't know if those reduce or not. So I went ahead and got two answers first because I thought, well, it'd be good to see what my two answers are. I'm pretty sure the first one reduces. I don't know about the second one, though. But I know that 3 goes into that 5 over 3. Does 114 over 9 reduce? 38 over 3. Now, well, I can't write on that side of the board. It's not orientated. Here's a clue, y'all. I was able to reduce this one by 3. So I thought if the other one was reducible, it'd be by 3 or 9, right? Do y'all know the rules about you can look at a number and tell if it's divisible evenly? Like, it's even, it's divisible by 2. If it ends in a 5 or a 0, it's divisible by 5. Does anybody know the rule for 3? Add your digits together. 1, 1, and 4 makes 6. Is 6 divisible by 3? Then 114 is. So that would have been a clue that, oh yeah, this is going to reduce. And then I wouldn't have to waste time putting in the calculator if I knew it wasn't going to. But once I realized it did, then I could reduce it, or I could just divide 3 in my head into it. Alright, so I chose to do this one Gaussian elimination, that first part of it, both ways, get rid of the x's and get rid of the y's, because my answer came out a fraction. I could have plugged the whole number in for y if I'd have got it, or x, but I didn't. Now in number 2, you have to make a choice, y'all. Let me move that up a little bit for you. 5x minus y equals 2 and 3x minus 6y equals 12. Our choice, we have to choose, because there isn't a variable right now that's going to drop out on its own, right? So I have to choose, do I want to make the x's alike or I want to make the y's alike? If I make the x's alike, then one of them's going to need to be times 3 and the other one times 5, and I'll have to change both formulas, right? And use a negative. If I make the y's alike, I could just change the first one. So you have choices, and that's why you need to look at both ways. If I just change the first formula, I can make my y's alike. So I'm going to multiply by negative 6. And why I'm multiplying by a negative is because they're both negative in the middle right now. So I need one of them to go back to being positive. So since I'm multiplying by 6 to get that 1 to change, I might as well do that too. So negative 30x plus 6y equals negative 12. And 3x minus 6y equals 12. Well, that's interesting. My 6's drop out, giving me negative 27x. What happened to my 12s? 0. They technically dropped, but you got to have something there because you need to divide. So x equals 0. Well, that's a nice point. Starts off with 0. So now I choose to go back to one of my original formulas to put that 0 in. I think it would be best to put it in the first one because the y doesn't have very much in front of it. Does that make sense? If I'm going to solve for y, I want to pick the problem that has the smallest number in front of y. So 5 times 0 minus y equals 2. I can plug that 0 in, and the 5 times 0 drops off because that's 0. Then this is negative 1y, so let's divide by negative 1, and y is equal to negative 2. Now, it wouldn't have been any harder if I'd have made the x's drop, but a little bit more work because I'd have had to change both formulas. But because I made the y's drop first and I got that 0, it made the second part a lot shorter. Now, I could have gone back and changed it and made the x's drop if I wanted to. You can actually do that every time if that's what you'd rather do. If you want to make the y's drop one time and the x's drop the next time, you can do that. But if you're plugging in a whole number, usually the math will go a lot quicker to plug that whole number in. So I want y'all to practice a little bit more. And as you go through these, I want you to keep in mind one other thing. Some of these might be no solution, and some of them might be infinite solutions. The difference between those two in Gaussian elimination is everything drops out on the left, but you'll have a number on the right that's not equal to the left for no solution. When you have infinite solutions, everything drops out. It's 0 equals 0. And that tells you it's infinite because everything drops. For a no solution, only the variables drop, the constant stays. And that makes it not equal to. So you might have a few of those mixed in with these, where we didn't have that the other night in our homework. I threw it in this time. So I'm going to let y'all have a little bit of time here to work on that, and then we'll see how long that takes. Alright, so we're solving algebraic systems. We're going to start with a quadratic and a linear equation so that you can see what do you do to make these two equations cross on the graph without making a graph kind of thought. That's where we're going. We're going to do it by hand. This is something that you need to be able to do if you are going to move on to higher level math classes, is being able to solve non-linear, quadratic, linear, quadratic, quadratic, whatever two functions I put together. And I have to limit this. I can't put absolute value in it. I can't put exponentials like 2 to the x minus 3 power. I can't put that in it. There's quite a few things. I can't put a square root problem in it. So that makes the math actually do almost the same thing every time, which is good. All right, so step 1 says set them equal. So always put your polynomial that has the highest power first, and then put the one that has the lower power second if one of them has more power than the other. Because you want to move it all to the left. So you want the highest power on the left. So how do I get rid of a negative 2x? Add 2x. And I'm going to do this vertically because that's how you work with polynomials, is you do it vertically. You also can do the plus 2 at the same time. How can I get rid of that plus 2 on the end? Subtract 2. And I'm lining things up because that's how you work with polynomials. You line things up so that you can keep them quadratic, linear, and constant in tow. So everything over here is now dropped out. This side over here is going to be what I'm working with. So I've got 3x squared minus 7x, because negative 9 and 2 make negative 7, and negative 4 and negative 2 make negative 6. So I have put them equal, and I've got it equal to 0, so now it's time to factor. What kind of factoring do I need? Is it in order? Is it need a greatest common factor out? No. Is it food line? Is it perfect? Is it 5-step method? Okay. So 3 times negative 6 is negative 18. That's 1 and 18, 2 and 9, 3 and 6. For it to multiply to be a negative 18 and add up to a negative number, the negative has to be on the bigger number. So that makes my pair of numbers that I need 9 and negative 2. And I'm going to put that 9 that's negative in my second hole and my 2 that's positive in my third hole, because I like my second term to be negative if I have a choice. Now let's split the problem. What can you take out of the first half? 3x. Okay, what will be left? Correct, x minus 3, because you can divide 3x into each piece. What can I take out of my second half? All right, plus 2. What will be left if you divide both of these by 2? So then we know we've done it right because they both came out x minus 3. So x minus 3, 3x plus 2 are my factors that are equal to 0. So that's kind of where the factoring homework stopped, because we were just practicing factoring. Now we've got to go back and learn again, what does this direction mean? Solve the binomial for the 0 of the function. That just means set both of them equal to 0 and solve. Now, after doing these for a while, some of you may find that you can solve that in your head. And I can show you that if you would like as we go along. But if not, you can always just do the math out. For example, if I set this parentheses equal to 0, won't I add 3? Well, don't that just look like the opposite? Solving just makes it the opposite. Does that make sense? Over here, I have 3x plus 2 equals 0. So I'm going to take 2 away and divide by 3. Well, let's think that through. The opposite of adding is negative 2. The opposite of multiplying is dividing. I could just think what the opposite is and make a fraction. And that doesn't reduce. So my two answers are what I get. That would be the x's for where they would cross. Now, yes?
Can we just change this? Can we just plug them in, check, got it right?
You can plug it in, check if you've got it right, yes. Now, the other thing is, that's just the x's. You see, when you go back up here to the original problem, these are the functions that if I typed it in Desmos and tried to see where they cross, they would cross with an x and a y value, right? So I've got to go back and take each of these answers and figure out what's the y that goes with it. Now, in that case, it should not matter which one I put it in. But a good rule of thumb is to put it in both, because it should have the same answer. And that would be a good check. Okay? So, for example, I could do f of 3 and g of 3. Now, whether I did that by hand or whether I do that part on the calculator is kind of up to you. I mean, you could do a little bit of that more with the calculator to check it and make sure you're on the right track. But 3 is not too hard to plug in this one, is it? Negative 2 times 3 is negative 6, and add 2 is negative 4. Now, this one would be a little harder to plug your 3 in, because 3 squared is 9 times 3 is 27, and 3 times 9 is going to be 27. That subtracts out and gives me negative 4. So I now know that one of my answers is 3, negative 4. I have to go back and I have to get the other one. The other one's not as nice, is it? So that's why sometimes using your calculator may be very helpful, because when you use your calculator, you're going to get there a little faster. So I'm going to talk about that just for a minute. So let me pull up my calculator. Because sometimes plugging a whole number in, you could do it in your head somewhat. But when you start looking at, okay, I've got to make sure that I know what I'm doing with this, then I might want to go back and say, okay, what would this be? So when I do negative 2x, was that plus 2? All right. If I wanted to look up 3, see how easy that is? You could just look up 3. Does everybody see what I did? Okay. But if I wanted to look up, was that negative 2/3? Negative 2/3 was my other answer. Then I would have to type in negative 2/3 here. And then I could go look it up. And it's 3.3 repeating. Well, I didn't get a decimal. Hold on. Ten-thirds. So again, you can plug the number in by hand if you want, or you can just go look it up on table. That's one way. Another thought, and I'll show you this thought too. 10/3. That was positive 10/3, right? Another thought is, if you want to look it up, another thing you could do is you could just do the math on the home screen. You could just plug the number in for x on the home screen and let it calculate it up all at once. That's another thought. But if you type it in y equals, you can look it up on the table. Now, if it's a fraction, you got to type it in the table setup, and that's why a home screen might be better for some of you. I don't know. If I had done that one I just did, negative 2 times negative 2/3, parentheses plus 2, for example. If I want to do it on the home screen, I can hit Math Frac right then, and it gives me the answer. And then I'd go back and I'd plug it in the other one to make sure it gave me the same answer, because that would be your check. If you did it right, both of them will come out the same. All right? Questions? All right, let's look at another example with a different kind of function. What if this time we have 2 quadratics? Last time I put the quadratic first because I had a choice between quadratic and linear. Now I have 2 quadratics. Does it matter which one I put first? Technically, it does not. Do you like negatives? Then put the one with the bigger number in front first, because that'll make a difference in your math. I always pick the one with the highest power and the biggest numbers to put in front. So 3x squared plus 12x minus 5 equals x squared minus 2x plus 1. So again, I chose that because 3 was bigger than 1. So we've got to move 3 terms from the right to the left so that we can factor what's left. So again, how am I going to get this x squared over here with 3x squared? That's right, subtract x squared. How am I going to get negative 2x over there? Add 2x, exactly. And I'm lining them up under the correct terms so my math will go quick. And then, of course, to get rid of a positive 1, what am I going to do, Josh? That's right, I'm going to subtract 1. If I do it right, everything on the right side always goes away, and everything on this side is going to be something that should factor. If it don't factor, then that means you should go back and do the graphing thing with Desmos because you got some nasty decimals coming your way. Step 1 on factoring. Is it in order? GCF? Yes. I have a GCF. I need to take a 2 out. It'll make my life easier. Did I do that right? Okay. I must have wrote this problem down wrong. That don't factor. Everybody see that? There's no way 3 times 1 is going to ever come out 7. That's okay. We can eat at least 1 this way, right? So what do we do when we get to that point in the problem and we see it's not going to factor? We stop and we go graph it. We go put it in Desmos and we get the answer. So how everybody does that real quick. Go over to your Desmos, put the original problem. Go back to the original problem. Don't put this in. Put the original problem in. Because if you're going to use Desmos, you want to do the whole thing with the original. Type your quadratics in the first 2 lines. Don't have to put the f of x, g of x part. You just have to put the quadratics in there. See where they cross. They're probably going to have some really nasty decimals if they cross at all. Is it a possibility they could not actually cross? Might. Although I think they will. I just don't know how many times. Now that makes me wonder what typo I wrote in here, because I worked these out ahead of time to know what they were, but I typed it wrong. Where did I put the notes for this? Okay. I didn't have them be the opposite. All right, anybody get an answer on Desmos? Does it cross? How many times? Twice. Really nasty decimals? 1 is and 1 isn't. Okay, so what is the nice answer? 1, 0. Everybody agree? And then the other answer is what? Okay, is that what everybody's getting? Okay, so everybody's getting a little something different. And it could be that, you know, if you don't click your cursor right on the intersection, it might give you numbers real close to it. But the key is, based on what I see here, I'm definitely thinking something's going on. I'm not even surprised that you got 1 that was nice. So I think that's interesting that you got 1 that was nice, because I didn't think you was going to get any that were nice. All right. So if you come down to it like that, yes. You got 2 nice ones? You didn't get any nice ones. Okay, well, let me look at that too with y'all. See if I can find my Desmos. Now, mine looks different from yours because I have the generic app. The generic app allows you to sign in with your Google and actually take a picture of any graph. That's how I put the graphs on your test. So originally we have 3x squared plus or minus. What was the problem? Plus 12x minus 5. I don't know if it's going to like those x's. I'll go back and see if it'll let me put a lowercase. I think I got my caps lock on. Alright, now, what's your other equation? X squared minus 2x plus 1. Well, I got equal 1. Alright, so here, this place right here, that's a nasty decimal. Is that the one you was talking about?
Yep.
Is that what everybody got?
Almost the exact same. Number one. When I put mine the exact same, nothing's like that.
It might be because of your screen may be zoomed or something, but it should be the same numbers I'm clicking on. All right, I'm going to go out here and see if I can find the other intersection. Way up here, right?
It was
About right there? And that's hard to tell. Let me go back out.
you can scroll it. You can like.
Yes, I should scroll because that would be better instead of zooming. Is that what y'all got?
Yes.
Negative 7 point something and 70 point something? Okay. So that just proves that if you type it in here with the original ones, you will see why it didn't factor is because it's giving me these awful numbers, which means I should have used quadratic formula to solve it. But we can use our calculators to solve it. All right, let's look at our next one. Before we get into the next question, I wanted to review multiplying because in order to do a quadratic or linear problem, it was just moving terms around. But when you put a fractional polynomial type problem in there, then you got to know how to do some multiplying. And I didn't know how much you remembered about multiplying, so I thought, well, we'll do a few samples real quick. So I've got 4 samples here. I tried to pick a variety of signs, a variety of different things that we can multiply together. Typically, you probably won't see too many like this one, because that's a shorter problem. That's food line. The rest, we have to do the whole, what we call FOIL method. First out or enter last. So first means first times first, which will be 6x squared. Outer means pick the 2 on the very outsides, which in this case is 12x. Inner is the 2 in the middle, which is negative 4x. And last times last makes negative 8. If you do it right, there will always be 2 terms to add together in the middle. So that adds up to 8x, and you'll get your quadratic. So we're going to have some problems that we're actually going to have to multiply something together and then move everything to one side. Now with this one below it, the reason I don't have to do the whole FOIL process with this one is because look at the outer and the inner terms. What are they? The same, basically, except for one's negative and one's positive. This is what we call a food line when we're factoring, right? They look the same, but they're opposites. I call that food line because you only have to do first, which is 16x squared, and last, which is negative 25. And that's why I call it food line instead of FOIL, because that shortens it to tell you you don't have to do the outer and the inner, you just have to do first and first and last and last. So that's a little quicker, but you don't see that as often as you'll see doing the whole FOIL process with what I'm about to show you. Now, let's look at a couple more. So in this problem, I have both parentheses have a subtraction sign, where this first one I did had a 1 of each. Let's see how that plays out. So first times first is going to be 20x squared. What's my outer going to be? Negative 20x. What's my inner going to be? 2 in the middle. Negative 10x. And what's the last in each parentheses multiply to give? Positive 6. So these two in the middle are both negative. So they add up to negative 30x. Now I want to talk to you just a minute about this for a reason. I want you to think about it. We've been multiplying 20 times 6 to see what adds up to negative 30. Because we've been trying to figure out these two numbers every time. So when we did all that factoring with 5-step method, we're unmultiplying full. Because we're trying to figure out what was these two numbers that made that number when we factor. Now we're going to be actually multiplying them out because we're going to have two problems that need multiplying together. Do I need to do another one? We feel good, okay about that. Feel good? All right.
Sorry for the interruption. I need Tiffany Tilley to call extension 210. Tiffany Tilley, 210.
All right, so with this one, you can see on one side I have a linear, and on the other side I have a fraction. That's called a rational function. And when you have one that's a fraction and one that's not, you want to make them both fractions. So we're going to stick a 1 under that, so it'll make it look like it's a fraction. Now, that turns my problem into a proportion. You're used to working proportions that look like this, and you cross multiply and divide, right? Everybody agree? That's the kind of proportions you're used to, is cross multiply and divide. Ours are still going to be cross multiply, but we're going to have to do a little bit more work than just divide. So when we multiply this way, we're going to multiply those two parentheses together. And when we multiply the other way, it's just going to be 1 times the top, so it's just going to stay the top. Does that make sense? Now we're going to have to multiply these two together using FOIL before we can do anything else. Everything has to be multiplied out. So first times first is going to be 9x squared. The outer, negative 6x. The inner, 12x. And the last times the last is negative 8. That adds up to 9x squared plus 6x minus 8. Then I can bring the other side down and make it equal to it. That's a 7. Looks like a 12. Let me fix that. And then it turns into one of the questions that we were just doing. Does that make sense? If we can cross multiply and get it all multiplied out, we can bring everything to one side. We're going to take 6x away. That makes 9x squared. This is going to drop out. We're going to take 17 away. That's going to make negative 25. What kind of factoring is that? Perfect squares. No, well, they are perfect squares, but it's called something else for factoring. Because perfect squares has a middle term. But they are square rootable, like perfect. This is food line. So when you don't have a middle, it's like doing perfect squares because they're square rootable. But it's one of each. Where perfect squares, you only write one parenthesis squared because they're both identical. These aren't exactly identical because one's positive and one's negative. But they do have perfect square numbers in them just like perfect squares do. All right. Now, again, let me show you that if you want to solve this without actually having to show any work, all you have to do is say, what's the opposite of subtracting? What's the opposite of multiplying? You just got to think the two operations and make a fraction out of it. So the opposite of adding that would be subtracting that. The opposite of multiplying would be dividing. So here are my x's. Am I done? No. I am not done, but I've got my x's. I know I'm going to want to know about 5/3 and negative 5/3. Now again, when you're looking at the original problem, if you're not real concerned about checking your answer, you only have to put it in one of them. And the one that would be the easiest would be this one. If you're concerned about checking it, then I'd put it in both of them. And one of the things you could do is put it all in your calculator at one time. For example, now I didn't do this a minute ago when I put it in the calculator, but I'm going to do it this time to show y'all how much quicker you can make it go. So if you put your first equation in there, the original problems, and then to put in fractions, you got to put parentheses around the top and bottom because your calculator's not smart enough to know how to do dividing without parentheses, because it's a grouping symbol issue. It doesn't know you mean fraction if you just put a divide symbol. All right, now I need two answers, right? I need something for 5/3 and I need something for negative 5/3. So I'm going to go to table setup. I'm going to type in negative 5/3. I'm going to go to table. Now there's a reason why I put both of them in there at the same time. If you put them both in there at the same time, if they match, you know it's right, and you know what the y value is. Does that make sense? So now I know the negative 5/3 goes with negative 1. Now it's time to put in the positive 5/3. And I don't see positive 5/3 on here, so I've got to go put it in. It doesn't know that I want to do that. I got to put that number in under table window, second window. And now here's positive 5/3, and they're both 9, which tells me I did it right and that the answer is 9. So when I go back to here, and I want to write my answer, 5/3 goes with 9, and negative 5/3 goes with, what did I say? Negative 1? Negative 1. So you can get that little piece off your calculator, but the rest has to be done by hand. All right. Now, is that enough to get y'all going on this? All right. Well, I'm going to let y'all work on it now. You got about, what, 20, a little more than 20 minutes to get started so you can see how it's working for you. And I want to put on that same assignment you were just doing. That way there'll be more answers to take off less per answer in case you missed one.